Thanks a lot. Yeah, one of the first papers we wrote about HTAP translytical was about 7 years ago. That time the industry was very young. No one thought we're going to be doing this translytical for so long, I guess, 7 years ago, right? We saw the need that people want to run analytics at the speed of transactions. As soon as the transactions are happening, we need to actually run insights. And there's always a gap, right? Like gap is like we got to move data from transactional systems to the operational systems to the analytical systems, and then it comes to a dashboard. It's 24 hours late. How can we get that in a second? It's so difficult to do, right? And that's exactly what translytical and HTAP is all about, right? So if you look at it, we have been building tightly coupled applications for decades. I've been doing database work for more than 3 decades. And what's interesting is that this is how we used to actually build applications. CRM systems separate, ERP systems separate, e-commerce systems separate. And then each of these applications had separate database actually. And this database was different from that database and that database. And then we're not able to share this data. And we had to do a lot of data movement. If you look at the down arrow, right? ETL. And ETL is a big thing actually because it slows you down, I guess, right? Imagine moving terabytes of data between these systems. It's such a nightmare. And this exactly is the real world, right? This is where we are coming from. And, the whole notion of transactional separation, operational separation, analytical separation came into existence because systems were overloaded, right? Systems were running with mission critical systems with transactional systems, and this required low latency access. You could never run a table scan on transactional systems because it will bring the system down, I guess, right? The CPU used to get maxed out and what have you, right? So these were separations out there, and this is exactly the data movement. Now, this has worked very well for us for the last 2-3 decades, I guess, in existence of the IT systems. But now people are realizing we need to run this quicker and faster as opposed to running it on transactional systems. So, and the volumes have grown. We're running into terabytes and petabytes of data, right? And the big issue right there. And then obviously separation of business intelligence, BI stacks. And then we got mobile stacks separate. We got CRM stacks separate. As a result, multiple stacks have emerged, creating silos, I guess, right, for the people. Now, right now, we got all these silos running, and these silos may be running in the cloud, actually, on AWS, Azure, Google, and it creates a bottleneck, right? Like, how do you actually drive more value from data that needs to be available, right? So, we talked about it, what was translytical. This is one of the first papers we wrote in almost 7 years ago at Forrester, when we demonstrated that, well, there is a need for this reference architecture which says I can run multiple workloads, whether I'm running analytics, operational insights, or transactional at the top layer from a single database itself. Like, why are we moving data around? A data movement is going to be slow, right? And this is exactly the reference architecture which says, okay, why can we do it now versus why couldn't we have done this 10 years ago, right? 15 years ago. What's the difference now versus previously, right? And the big thing, I think, is this whole notion of in-memory processing. The in-memory has been the big focus with DRAM prices falling down and flash and SSD. You can put a lot of data in memory, and memory is 1,000 times faster than your disk drives, right? Which is why we are able to run this translytical, because of the fact that you can run all kinds of workloads into memory processing, which is one big thing. Plus, it's also got scale-out architecture, which means I can actually run across multiple of these servers together in a scale-out, which means the distribution of data is there into partitions as well, which is impressive. Compression of data is critical because you can compress data into a lower denominator as well. And intelligent tiering as well. This is an important aspect because you can put data into DRAM and flash and SSD depending on the data requirements as well. So huge thing as well, what we have seen. And streaming data coming in from these different scenarios as well. So this is basically the fundamental of HTAP in terms of running analytics at the speed of transactions. Now, having said that, obviously a lot of things are changing, right? This is what you'll see from a lot of vendors, including TiDB, doing this reference architecture. And we do see changes happening, which is where the future lies, right? What is beyond this architecture in terms of the platform? So what have we been doing is that the database itself has been supporting all kinds of workloads. It ensures data consistency. It ensures transactional integrity. It ensures analytical accuracy as well. So huge things in this element as well, right? So an important element here is about data consistency is very important. Data needs to be consistent. If the data is not consistent, it's probably pointless to actually run translytical, I guess, right? It provides the performance and scale needed through memory architectures. Very, very important. The architectures for translytical is that you can run across DRAM, you can run across flash, SSD in a very tiered manner itself. Some critical data will be in DRAM, some critical data will be in flash and SSD and what have you, right? So it reduces the complexity of this architectural thing as well. One of the biggest issues people are running into is complexity of architectures right now. The data could be used for different systems, but they're not able to drive more results quicker and faster because of the complexity of these systems, right? Especially you got business intelligence. People talk about real-time insights, right? Real-time analytics. But question is, how many people really define what real-time means? Is it seconds? Is it milliseconds? Is it hours, days? Everyone has got a different opinion about that as well, right? Huge thing from what we see as well. How many people are going, I guess, doing real-time insights today? Real-time analytics. What is the definition of real-time for you guys? Yeah. So no, exactly. I'm saying this is real world. This is real world. That's exactly as real world. And you know, you can't do in seconds because the architectures are always a flawed thing, right? And that's exactly the whole issue. But I had one customer mention to me almost like 24 hours as well. So it's common. Real time, it could be 24 hours. In fact, if you ask 10 people in the same organization what real time means, you may get 10 different answers, which is okay. Eliminates the need for supporting multiple databases, right? Because you don't have to have multiple databases for infrastructure, data movement. In fact, people can save money with translytical. This is very important. Your management needs to know that. Why? Because you can eliminate databases altogether. You don't need to have so many different databases running altogether. Big trend. Infuse transactional application with real-time insights. I think this is a big thing which really drives more value and accelerates new insights which were not common, which was not possible before through a common platform itself. Okay, so translytical benefit goes beyond supporting multiple workloads. You can see real-time use cases are there, supporting hybrid cloud, on-premises cloud, supporting faster, agile platforms, lowering cost, as I mentioned, competitive advantage, administration benefits, and delivers consistent, trusted data as well. And this is huge. And I want to give a comparison about, okay, how do you compare transactional databases with operational databases, data warehouses, and translytical? Right? Are they optimized for transactions? Yeah, transactional databases are. Operational databases are not. Data warehouses are not. Translytical is. Optimized for operational, yeah, transactional databases are not, operational are, but translytical does operational as well. And as well as analytics, data warehouses have always been optimized for analytics, but when it comes to translytical, it can do all those things as well. Insights for real time is limited. This is a very important point. Data warehouses today struggle. If the data is not in the warehouse, you can't do analytics. Simple as that. So this is a big issue right there. So data has to come in, and I think translytical actually helps you because it can provide you that whole notion of data in real time as well. Multi-workload management. So the biggest problem with translytical is that you have to run multiple workloads. The workload management has to be very good. Imagine someone running a table scan with a transaction at the same time in a database. the CPU will just spike, I guess, because your table scan make it a higher priority. So you have to ensure that there is a better workload management, which says based on the priority of the workloads, you may get better CPU, more CPU for this workload versus that workload. Transactionals always get higher priority versus the operational workloads and analytical workloads as well. AI machine learning obviously has got limited. Transactional databases is now starting to introduce AI machine learning, and Translytical obviously is having multiple workloads for AI machine learning as well. So you see, Translytical actually has an advantage. I always recommend customers that at least 20% of your workloads should be running on Translytical. Not everything should be running on Translytical, but at least 20%. So depending on the scenario. And we are seeing a lot of use cases for Translytical HTAP, right? People call it HTAP and Translytical, same thing. HTAP is hybrid translytical, transactional analytical processing, and Translytical is what the Forrester terminology is all about. So what are the use cases we see? Well, real-time focused applications like fraud detection, patient health monitoring, airline reservations are there, commerce are there. There's also personalization, recommendations. And I think the list goes on and on. What we're seeing mostly is to doing with real-timeness of data. We're doing predictive analytics, or if you're doing real-time analysis of gaming, risk management. I think every industry is having a benefit for Translytical based on a conversation as we see it. Today, we see the adoption in the industry about 17% across financial services industries, retail, manufacturing, oil and gas, e-commerce, and others as well. 17% adoption, and we believe this is going to double in the next 4 years to about 34%. And I think it all depends upon how people are really going to embrace it further. But this number has been going very aggressively. I would say it could double in 3 years as well, depending on how the adoption kicks up. So where are we going in terms of the future of Translytical, right? And I think this is a very important direction, and I'll talk more about where we're heading towards the future. Certainly, there's many things happening in the future of Translytical. A couple of things we're going to see and talk about is multi-model. Multi-model is a very important direction for Translytical, and what it means is that being able to support multiple models. We're talking about JSON, we're talking about graph, we're talking about key value store, and these different models could be built itself within Translytical. You don't need to have separate databases for key values separate, and documents separate, and graph separate. Let's bring them together in a single model, single platform itself. Multi-model has been growing in terms of adoption, and we're going to see a lot more action around multi-model coming to existence, especially as people start to build these microservices applications and build these more advanced edge applications as such. There's also the feature store to store all of your AI machine learning models itself, which has been gaining a lot of traction as well. So we're going to see a lot more happening in this Translytical world for feature stores to support these environments. Data intelligence is something which is very early on, which means that the platform itself knows what data is coming in. As you load data, the platform itself automatically knows, by the way, you're loading this data is credit card data automatically, without actually having someone to actually program this. This intelligence is still coming in, but probably in a couple of years, you're going to see this platform becoming more intelligent and adaptable. Built-in governance is another one which we're seeing. Governance is playing a big role, I think, in every industry. And I think you're going to see a lot more of governance, controls of data, accessibility, and what have you. I'll talk about more distributed data and global integration. Let me talk about that as well. But Translytical is about OLTP, OLAP, metadata, and data. Okay, now this is a very important slide, which is where we believe this is heading towards, is global transactions that can span across multiple regions. So we're talking about here from San Francisco to Germany to Singapore, where you may have Translytical platforms being able to synchronize the data across transactional purposes. And we are talking about global transactions because you can drive low latency access to this data. And the good thing is here you can build applications in Singapore or in Germany, but the data is all synchronized across all of these scenarios. Traditionally, we have done this, but manually. We're talking about an automated way of building and deploying this as well. So distributed architecture is something which we are going to start to seeing a lot more in the coming year. And the good thing is you don't have to worry about transactional integrity. It's all taken care of automatically by the system itself. In terms of committing transactions, roll back the transactions if at all they were not successful. And traditionally we used to do two-phase commits, as you know, but we are talking about more sophisticated transactional algorithms to actually solve this as well, which will be interesting. But traditionally, applications used to take care about transactionals of data consistency between here, and there, but we're talking about translytical taking care of that consistency. Another one which we have seen emerging as the future of translytical is the notion of having data. Translytical platform, as you know, consists of multimodal, consists of data, and being able to service all kinds of workloads. But we are also seeing the ability for the translytical platforms to connecting to other data stores, like customer databases, like a Salesforce, like NoSQL, like legacy databases, and being able to synchronous or async, depends on the protocol you're trying to use. So data could be distributed across other stores as well, not just within a translytical platform. Traditionally, you were only servicing, all data had to be here to service through APIs, through SQL interfaces, but now this translytical can also interface to other sources of data towards supporting distributed transactions. Now, this is growing in acceptance, which means that you are able to run across, say, MySQL, across Postgres, across other types of databases like Salesforce environments, or other types of environments like Amazon's Dynamo or DB as well. And the good thing with that approach is that you're able to bring together the bigger ecosystem of things to integrate, to synchronize. And this, we believe, is going to be huge in coming years as well. Now, and the real reason is that not everybody cannot move all this data into a translytical platform, yet they want to maintain these for their own legacy reasons, I would say, right? Okay. We are also seeing an improvement around AI, generative AI, LLMs, where we are seeing vector embeddings coming in as well. So translytical is also now expanding towards supporting these vector embeddings, where you actually can load vector embeddings, and then actually you can build what you call vector indexes in these environments as well, through vector objects as well. So you load this data into vector objects, and then you create indexes of them as well. So we're seeing a trend around that. We are also seeing a natural language interface of translytical where you can actually query and also do copilot, building some of those what you call programs, interfaces to actually data, but also through LLMs integration and LangChain integration with translytical. This is very early on. We expect next year to see a lot more actions around LLM and LangChain with translytical itself. This is very early on, I think. But I think vector embeddings is going to be the big one, which is going to be pushed out by several vendors on HTAP this year. Yeah, so the recommendations, we have obviously look at translytical that can help your use cases. We do know it can deliver real-time insights for different types of applications out there. Considering consolidating your database silos to improve administration, this is something which I tell all the customers that you should consolidate your databases, especially to translytical platforms, because it can lower your costs, but also future-proof your database environment. And then keep security in mind when using translytical. I think security is a very important discussion, which people don't really sometimes understand. That how do we actually drive more value from this data, but also how do we protect this data, especially PII, PHI, but also sensitive data in nature as well. And then leverage translytical for global transactions as such as well.